Hey, okay then, namaste, adab, sat sri akal, how are you all? This is CS Sankalp Kanstiya and I welcome each one of you in this amazing session on strategic cost management and performance evaluation. Are you ready to learn something new? Then let's get started, buddies. Let's get started. So, lean 1, tick mark. Lean 2, bucket list ticked. Lean 3, done. Lean 4, done. Slowly but steadily, we are marching towards the completion of Lean 5 now. So we are going to start with Lean 5. And what a phenomenal change has happened in Lean 5. Awesome. If you open my lecture, which were recorded 2 years back, for this same cellular manufacturing and Roca, probably, or even a year back, yeah, even a year back, then in that case, you will find that, boss, this concept of lean 5 cellular manufacturing, I have completed in a matter of what? Half an hour or 1 hour maximum. But now, double the time is what it takes. So now there are sums in cellular manufacturing, and that's where this concept has become very, very important. So ICAI, through its RTP of May 2021, introduced a phenomenal concept of rank order clustering algorithm, which is an extension of Lean 5 that is called as cellular manufacturing. Then they introduced two special sums of rank order King's algorithm, rank order clustering algorithm, and what a fantastic sums they were. When they first came in the RTP of May 21, the sums were such that I had seen them for the first time in my life. The concept of Roca was totally new for any professor of probably costing who is even into this field for the last 50 years. So a totally new concept introduced by ICA and definitely very important for your examinations. So what exactly is the concept of Roca, which is very important, which has sums into it and which can be asked in the examinations. And before that, before Roca was introduced, we had Lean 5 cellular manufacturing. So what exactly is your cellular manufacturing? What is Lean 5? Is now what we are going to understand in today's scenario, right? And the theme of today's session will be change is the way of life. Change is the only constant in life, or change is imminent. It will always be there. So on that note, let us quickly get started with this concept. All right. So now we are going to understand three levels of Lean 5. As I told you, in the previous system, yeah, as I told you, in the previous system, so probably before this ROCA, ROCA that you can see, before this was introduced through May 21 RTP, this Lean 5 was at a very nascent level, was at a very beginner level. And then eventually the things started turning up to a very nice extent. So what I usually say to my students is that previously it was just at CA foundation level. Then they introduced the concept of ROCA, CA intermediate level. Then they introduced the sums relating to ROCA, CA final level. So obviously now foundation, intermediate and final, all of that is what we are going to study in our context. So what is your CA foundation? So what is your CA foundation? So here we will say that this cellular manufacturing, this ROCA Roca, this cellular manufacturing, this ROCA Roca is what? It is actually a lean system through which the waste of motion, if you remember, unnecessary movement of men and machine is stopped to a very great extent. I told you in the first lecture when we started this chapter that lean system and innovation has 7 waste. And our role as a management accountant is to ensure that those 7 waste are removed. For which we started our journey with just in time. Then we went on to Kaizen, then 5S, then TPM, total productive maintenance, and finally here we are with cellular manufacturing, which ensures that the waste of motion is stopped. Through JIT we saw that overproduction. Tim Wood, you remember, no? So that overproduction does not happen. Through JIT, we saw that inventory, which is WIP, is not unnecessarily piled up, is not created. So I and O was taken care by just in time, right? Then Kaizen will ensure that unwanted costs are not incurred and small costs are reduced to a very great extent. So over processing, if any, is reduced. So that ways here now we have lean 3 was there. So lean 3 probably focused on workplace organization. They ensured that there is no waste of time on things which should be easily done. And now we have lean 5. Okay, but lean 4 was also there. Lean 4 was on total productive maintenance. There is no machine breakdown of any sort. So as a result of which waiting time was reduced. So TPM focused on reducing the waiting time. In the same way, so the waiting time is reduced by something, then inventory overproduction is reduced by JIT, over processing is reduced by Kaizen. So in the same way, cellular manufacturings and Roca's main role is to ensure that the waste of motion, out of the 7 waste, the waste of motion is reduced to the largest extent possible. Are we understanding? And last we have is defects. Last we have is defects, which will be solved by Six Sigma, which is Lean 6. Correct. So Lean 6 focuses on so hardcore quality that there will not be any defective products. So 7 waste all removed by these 6 techniques of Lean, of which now we are focusing on Lean 5, whose focus is on removal of of motion. Tim. Third waste, removal of, so Lean 5 is introduced for removal of third waste, and that is motion. And that is motion. And if this third waste is removed, if this third waste is removed, then in that case, I think it will be a very, very good thing for the company. Gotcha. So I told you we have divided for our understanding. See, when you will revise, the biggest thing when you people start their revision is the time factor. So a lot of time is being going. Second most important problem that is faced by students is, sir, we are not able to recollect what was taught. What was taught. So that it becomes very important that we ensure that our notes are in such a way that we are able to recollect everything. So for that we will write here CA foundation so that you recollect. CA foundation is the traditional manufacturing system. Sir, what is traditional manufacturing system? I will explain you, macha. Then we have CA intermediate. We have CA intermediate. What is CA intermediate? That is the introduction of the new hero, which is cellular manufacturing system. And what is the third, which is CA finale? And that CA finale is your rank order cluster algorithm. So what happens is, first you are at CA foundation level, and that's where you realize that no, this traditional manufacturing system is not working the way it should. This traditional manufacturing system is not working the way it should. It is not working at a level where, traditional manufacturing system is not working at a level we would want to see. There are a lot of wastes which are happening, and therefore, see, necessity is the mother of invention, right? So we realize that this traditional manufacturing is resulting into a lot of waste of time, resources, At the same time, there is a lot of overcost which is involved. So must we need to change, right? Only once you find some issues, some problems, will you want to change it, right? As is the case with any other thing. Say, for example, today companies are public limited companies. Where did this public limited companies, joint stock companies where people can invest came into the picture? It didn't start it that way, right? How it all started was through sole entrepreneurship, correct? So it started with sole proprietorship. Then there was a need felt that a single person cannot run everywhere, and giving rise to the partnership firms. Then they realized that partnership firms also there are limitations, giving rise to LLPs, then the private limited companies, then the public limited companies. So there are so many options which kept on evolving. As I told you, necessity is the mother of invention. There was a necessity felt that this particular organizational way is not able to solve my problem. So I will have to evolve. So I will have to evolve. So I will have to evolve, giving rise to the concept of cellular manufacturing and Roca. Cellular manufacturing and Roca. Hey, samjigudu. So that's how it all came into the picture. So then what's the problem with traditional manufacturing system, sir? So yes, first let us understand that, and sorry, what's the problem with traditional manufacturing system, and then we will move on to our new system and see whether the new system removes all the problems of traditional manufacturing system. Obviously, it did remove, and therefore it was implemented. And the implementation strategy of cellular manufacturing system gave rise to the Roca. So what happened? There were few disadvantages in the whole concept of traditional manufacturing system, giving rise to the concept of cellular manufacturing system. And then we realize that yes, this cellular manufacturing system is good, giving rise to Roca. So in order to implement this Roca, we will have to understand it through proper formulas and through proper diagrams and connects. So I hope all of us are ready to understand all of this. I hope you understand what are the things that we have to study and where is it everything coming from. So we are going to study now end at CA finale. But this CA finale will end where? Yes, before first we will have CA intermediate. Then before that we will have CA foundation. And then obviously the CA finale will end. So let's start with CA foundation. So what was the traditional manufacturing system? Just to give you an idea, traditional manufacturing system focused on multi machines. Focused on multi machines. Whereas current or new system called as the cellular manufacturing focuses on multi-process. Focuses on multi-process. So what's the difference? I'll tell you. What's the difference? I'll tell you. See here. In case of traditional multi-machine, in case of multi-machine, the focus here is on big machines. The focus is on big machineries. Big machineries. So for example, now try and understand the example that I'm going to create. Okay, suppose we have our own company. Suppose we are the owner of, say, let's take any Indian manufacturing company, say the Tata Group, correct? So Tata manufactures motors, correct? So in fact, Tata is there in everything. There is not even a single product which they are not into, be it from the airways, correct? Now Air India is Tata's, to a small pin that also is available with them. They have Taj, wherein they are into Horeca. You understand Horeca? Horeca means hotels, restaurants and cafes. Yeah, so they are into the business of Horeca. Then yeah, so they are into the business of Horeca. They are into the business of airplanes. They are into the business of what not? Tata Motors, Tata Power, Tata Consultancy Services, which is their flagship brand for IT services, which is one of the most valued companies on the stock exchange. Do you know? TCS is amongst the top three most valued companies on the stock exchange. So huge level of uh, work that Tatas have done. So let's take an example of Tatas. Lifestyle brands, so many things. Chroma they have, which is into electronics, so on and so forth. So let's now start with our understanding. Yeah, FMCGs they are into. That's right. So as I told you, there's hardly anything left which they are not into, right? Okay. So focus is on big machineries. Now, what used to happen in these big in companies, manufacturing companies is they used to purchase these big machineries, big machineries, big machineries. So this is say for example machine one, and they based on their machine, say this they used to name it machine two. Then say they used to name this machine 3. So they used to say it that say this is the cutting department. Say this is the drilling department. Say this is the uh, any other department that we want to say, milling department. Okay, chalo. Say this is the milling department. Want to exchange drilling, milling, cutting. We'll do it that way. Just a moment. Drilling. Then we have the milling, and then we have the cutting. Suppose these are the three departments. And obviously, if I talk of Tata's, obvious, they are the biggest brand that India has seen, biggest brand for almost everything. They are into so many products. They are into so many products. So, for example, Tata's now have a manufacturing plant or a factory, and they produce product A, they produce product A, product B, product C, product D, etc., etc., etc. Product A, B, C, D, etc., etc., etc. Now, in these big manufacturing concerns, what used to happen is, suppose there is a drilling department that you see here. Suppose there is this drilling department you see here. The main role of this drilling department is only to do one thing, and that is continuously do the drilling part. Drill. That's it. There will be one operator who will be in charge of this drilling department. There will be one operator who will be in charge of this drilling department, and he has only one work, and that is drill. So product A will come to him. All the drilling work of product A will be done here. Then product B will come to him. All the drilling work of department will be done here. Then product C will come. All the drilling work will come here. We'll do here. Then it will go to machine 2. All the milling work of product A, B, C, D, whatever other products will be done in case of machine 2. Then say for there is machine 3. All the cutting work of A, B, C, D, so many products are there, will be done in machine 3. So I hope you can see and observe that previously in traditional form of organizations, the focus was more on having big machines, and those big machines were only doing one thing: drilling, milling, cutting. Now that created some issues. I'll tell you the first issue, which we have probably discussed to a certain extent when we were doing machine cells. If you remember, JIT issues, group working machine cells. Correct. Yes, Lakshmi Prasanna Adavi has absolutely pinpointed that. And if you remember, I told you that time also. Even in the book, I have written it that machine cells is almost a similar concept to your Lean 5 cellular manufacturing. So let's focus. So here in this drilling department, all of this work is going on, and this drilling department works at 100 units per hour. Works at 100 units per hour. So if product A has come to the drilling department for doing some drilling, then by default, as one setup, it will produce 100 units per hour for this drilling. And now these machines are very big. These machines are very big because they are so specialized that they are big machines. So what happens is, suppose this product A, they have made 100 units per hour. Now this product A will also require some other work other than drilling. They will also require some milling. So what will happen is, then this product A will be transported. So a lot of motion used to happen here. So what used to happen is, people started traveling from one place to another. Then there, so traveling of people was there. Then then motion of goods was there. Motion of services was there. Why? Because one department, because it has big machineries, was different from the other department. So say for example, drilling department is on the ground floor, milling department may be on the first floor, cutting department may be on the second floor. So then now first floor, this A 100 units have been produced. Chalo, now starts the motion of goods, of people, of inventory. Then we will go to the first floor. There the milling work will happen. Now milling department says that, boss, you have bought 100 units for milling. Drilling work is done. Now you have bought 100 units. But boss, my capacity is only 80 units per hour. Boss, my capacity is only 80 units per hour. So if I start the milling work here per hour, then still you have bought 100 to mill, but in 1 hour I can mill only 80 units. So there will be an issue with that also. So 20 units WIP will produce, macha. 20 units WIP will be collected unnecessarily here. So 20 units every hour, 20 units WIP, work in process, will be gathered here. 20 units per hourly basis, work in process will be gathered here. Are we understanding, guys? Yes or no? So this WIP will keep on increasing. Now suppose this milling department does its work and then sends it to the cutting department. Cutting department says, hey, hello, my speed is only 50 units per hour. Again, some more WIP will be created here. So obviously this is against the system of JIT. And obviously this does not work, because WIP will be created, managing that stock. If that stock gets any issue, then in that case a problem, then such huge movement is to be done. So that is a problem. Milling department may say, no, I will not keep all of this, you please transfer it to machine one. So he may not keep all of that. So there were a lot of issues which started arising as the number of products kept on increasing. As the number of products, see, when there are one or two products, which was the case previously every company used to make hardly one or two products, but now people have started going into multi-product scenario, and therefore using this system became a big problem, became a big drawback. So this is how it works. Over a period of time, things become outdated and then you have to change, right? So what's the case here? So machine 1, 2, 3, machine oriented focus of traditional manufacturing somehow took a back step. Somehow took a back step. And a need was felt that some other better system should be evolved. Some other better system should be evolved, because this multi-machine system is creating these issues. Yes, let's quickly discuss these issues and let's see whether you agree with me or not. See, it started creating issues. Now suppose if I am the see, I am the production manager, then obviously I will face the major issues here. So I will go and tell my CEO, CFO that, boss, we are facing a lot of issues in production. In traditional manufacturing, we need to move. The first question that he is going to ask you, what is the problem that you are facing? First, he'll ask you the problem, then he'll ask you the solution, and he'll see whether problem is big enough for the solution that you are bringing. So we will have to discuss the problems first with our CEO, and then the CEO approves, and then we can move on to cellular manufacturing, right? So issues of traditional manufacturing. Issues of traditional manufacturing. Issues of traditional manufacturing. First was waste of time. Movement of process, men plus material. When did that happen? Say from ground floor to first floor to second floor. Even if it is on the same floor, still go take, because big machines were there taking units from one place to other. Plus, if there are so many products which are being made, say for example, machine 2 is busy on producing product B, machine 2 is busy on producing product B. Then in that case, even though machine 1 has done the work of product A will have to wait. Again, there is a pile up of WIP. OMG, OMG. So that is creating big issue. So first, there is waste of time, of men, of material. Secondly, because this WIP is being created, can I say my working capital is blocked there, yaar? Can I say my working capital is being blocked there? So blocking of working capital will happen, which again is a problem because financially it is creating a problem for me. Yes, Lakshmi is saying, cannot these issues be addressed by Kanban and working cells using simultaneously? Yes, ma'am, that can be done, and obviously that will be done. These things will be addressed by Kanban and working. So, what they came up with, combined Kanban and probably your working cells, and came up with a new system called as cellular manufacturing. So, let's take it that way. Gotcha. Okay. Then third is the storage cost. Now a WIP is piling in one machine. I have just given an example of 3 machines. There can be a case of 5 machines. So one WIP is piling somewhere, one WIP is piling somewhere. Obviously, you will have to store them. Where do you store it? On my head? No, sir. You will have to create a warehouse or a storage place, which will come with a cost. Which will come with a cost. So that will increase my storage cost. Are you understanding? Then comes the biggest issue. Pay attention now. Suppose drilling department has done its work. Suppose milling department has done its work. Suppose cutting department has done its work. And now it goes to the assembling department. And now it goes to the assembling department. And you will not believe, at assembling department, when the product was done, assembling department was assembling it, and they realized that the cutting of this part is not done properly. That, say for example, suppose they have made this. Suppose they have made this box, and the cutting of this box is not been done properly. So the assembling team's job is to assemble it. They are not able to assemble it. They are not able to assemble it. They are not able to assemble it. Why? Why? Because probably cutting is not done properly, or maybe drilling should be done in a proper way so that the edges are drilled properly and this can be done. So now, if there is any issue with the product, you will come to know directly at the assembling stage. Suppose the drilling department has not done the drilling work properly, you will realize this at the assembling stage. Oh, Jesus. Oh my God. Would you believe it? Now what will happen? Now assembling team will go to the drilling department and say, boss, drilling has not been done properly. Now if drilling will be redone, are you understanding? Then milling will also have to be redone. Then cutting will also have to be redone. OMG. So this will create a big issue. Are you understanding? So the rectification of defects happens at the last stage. Rectification of the defects happens at the last stage. So if anything has to be rectified, then in that case, you will have to go back to the department where you found the issue. And suppose if I found the issue in this box, then in that, at the drilling level, then we will have to go back to the drilling department. The drilling department will go all up through this, and then they will do it again. Obviously the connected department is milling and then cutting department, and everything will go for a toss. Giving rise to a reprocessing cost, giving rise to a reprocessing cost, which is said by Lakshmi Prasanna Adavi. That's absolutely right. So rectification of defects, it will consume time, it will consume my cost, at the same time it will cost me harassment because there will be quality issues with that. Obviously, I don't want them. So rectification of defects, such a big issue. Next issue. Suppose I need some customization. Suppose I want some customization for my product. Suppose I order in bulk. Suppose I am some big conglomerate and I order in bulk, but I need some customization. Now that may also not be possible because I produce in bulk. So making that customization may not be possible. I'll tell you why. Because suppose this is the drilling department. Now this drilling department is doing the drilling for all the products A, B, C, D. Now only product A needs some particular customization in drilling. Now obviously this drilling machine cannot be changed only for product A. Everything else will then go for a toss. So there is no scope for customization and unfortunately no scope for flexibility as well. Are you understanding, guys? What are the issues that are being created? No customization possible, no flexibility possible whatsoever. And this is where big issues started coming in. Because see, today is a world of customization. And today, if you're not able to provide your customer with the customization, then in that case, he may not come back to you again, which is a big problem. And in big machines, the setup times are huge, the batch size is huge. But suppose if I belong to a fashion industry, suppose I am the owner of Zara and I belong to a fashion industry, then in that case, I don't want big batches. I want small batches because anytime my fashion may change. Just imagine, for a costing professor, I thought when I started costing that costing, no, it's a static subject. What will change? Only few sums will be added here and there. But look at them, they are changing the concepts. Now, suppose if I print 25,000 books at once, then in that case, and if ICI changes the portion, then everything can go for a toss. Are you understanding? Then the books have to be revised. Then things will go haywire. So, as a result of which, traditional manufacturing again becomes a big issue. And the last but not the least, suppose, God forbid, but things are going smooth. But milling department, suppose milling department, this machine is not working. Milling department, this machine is not working. Now, if this machine is not working, then in that case, do you know what will happen? All the products A, B, C, D to Z, so many products startup produce, all of those products will get stuck. Sir, why? Because every product needs milling, but that milling machine, that department is gone for a toss. They are not following TPM also. Yes, now what will happen? So just imagine all the products will go for a toss and none of the products you will have be able to make. The whole factory will come to a standstill just because one machine is not working. Yes, entire process stops. Even one machine stops, all production comes to a halt. And therefore, this again is a big issue. Plus, I told you, high setup time is there. Maintenance cannot be done on your own. See, in case of small machine, see, yesterday we discussed TPM, total productive maintenance. In that, there was a system of autonomous maintenance, visual representation, and not visual representation, visual issues can be resolved. Then any lubrication or nut bolt issues can be resolved. So all of that was possible. All of that was possible in case of smaller machines. In bigger machines, how is it possible? The operator will not be able to operate that machine, as in will not be able to find out the issues because it's too technical. So there is no scope for autonomous maintenance. Now the CEO realizes the plight of that production manager and he feels, oh my god, so many issues are there. And the production manager says, yes, sir, yes, sir, yes, sir. And as we saw, waste of time, movement of process, man, material. working capital getting blocked, storage cost WIP, rectification of defects, lack of customization and flexibility. Even if one machine stops, all production comes to a halt. Lack of autonomous maintenance, high setup time, everything, every goddamn it thing is a big issue. So, sir, will your cellular manufacturing solve all the issues? Yes, it will. Yes, it will. So, sir, then please tell us. We are so excited to know that. Hold on to your horses. So, first you have to confirm me whether you understood all of this, whether you understood the issues of traditional manufacturing. Imachas, yes or no? Yes. Are you with me that yes, cellular manufacturing should be introduced? This system is not working. Sir, that we can tell only after we know what is cellular manufacturing. As of now, yes, we are convinced that this is creating issue and we should find out a better way. Yes. So that we are agreeable. Agreeable or not, Machas? Yes? Sure. So giving you all 2 minutes. Just have a look at this and then we will take things forward to the new concept of cellular manufacturing. And as I told you at the beginning of the lecture, change is the way of life. And this is the change that we will now need to embrace. The change of cellular manufacturing. Are we ready, guys? If yes, just go through these 2 minutes and then we'll move on to a new concept of lean-fi cellular manufacturing. Guys, please write this down. Please write this down. Start. Write this down. The case. So all of us are convinced that this will not work. छोड़ो कल की बातें, कल की बात पुरानी, नए दौर में लिखेंगे मिलकर नई कहानी. Cellular manufacturing. Chalo. So now we have presented to our CEO, CFO of the company that, sir, we are tired of traditional manufacturing. Then what do you want? Sir, bring in the concept of cellular manufacturing. And sir, this is our presentation to you. In cellular manufacturing, we will create cells. In cellular manufacturing, sir, we will create cells. Acha, what is cells? Sir, cells is basically going to be a cluster of machines. It is going to be a cluster of machines. Why? What will that do? So that too, preferably in a U shape. Preferably in a U shape. So we will have a U shape machine cell. Machine cell. We'll have a U shape machine cell. Are we understanding, guys? Tell me. Yes? Okay. So how will that help? Is the CEO asking me. Now pay attention here, Mr. CEO. Now in that cell, what will happen is, now in this cell, what will happen? We will have machines. Say for example, you had a drilling department. So this will be drilling machine 1. Then there will be a milling machine 2. There will be a cutting department, cutting machine 3. And then obviously the assembling will work up. Plus there will be only one person who will take care of all of this. But how will this solve all your issues that were created here? Sir, give me some time. I will explain you step by step, one by one. All yours. You can start the explanation. Okay, sir. So I'll tell you, sir. Sir, by doing this, One, we are creating multiple cells. So what these machines are going to be small machines. These are not going to be the big machines which we previously had. So this operator who was only doing drilling work now will also do milling work and cutting work. So he will be more involved. He will be more knowledgeable. He will like the work that he is doing. How is that possible? Sir, I'll tell you. Now I ask you, dear article clerks, there are two options. I send you to a big listed company where you are only going to do fixed asset reconciliation work, or should I send you to a mid-level company where you will also be doing scrutiny, internal audit, tax audit, everything? Where will you want to do? Go. A listed company where you are only going to do fixed asset reconciliation every day for 3 years, or you would want to go in a company where it's a mid firm, but where you will learn scrutiny, you will learn internal audit, you will get to do stat audit, you will get to do tax audit, everything. Tell me. Lakshmi Prasanna Adavi is saying, why U shape? I'll tell you everything, mancha. I'll tell you everything, machi, chechi, whatever. But you first tell me, which company will you want to go into? A specialized fixed asset reconciliation, or where you learn internal audit, stat audits, tax audits, GST? Definitely the mid ones or the second one. Everybody in one unanimous voice is the same answer. So will be the case with my this operator. Even he will, even he will want to ensure that he learns more things. He will take more responsibilities. Plus, because these are smaller machines. So if there is any issue, then this operator himself will be in a technical position to resolve the problem. If any, if there is a small minor stoppage, the operator himself will be able to resolve the problem. Himself will be able to resolve the problem. Samjhi. Then let's focus on the issues created by traditional manufacturing and see how cellular manufacturing takes care of all of them. Mind you, all of them. How, sir? So, let's see. First was waste of time, movement of process. In that case, you used to take from ground floor to first floor to second floor, or if it was same, you know, in the same vicinity, then in that case also you had to take so many things. In case of cellular manufacturing, what happens? This operator will first do the drilling work. Then he himself will check whether drilling is done properly or not. Then he will take to the milling department. He will check whether milling department as in milling machine. Now the reason for keeping it U shape is automatically it will go very fast. See, if I go like this and if I go like this, then obviously this is faster. You know, whenever you travel somewhere, take a route where you try to cut the route. So by using this U-shaped cell, you are cutting the route, and that is where things become faster, right? Lakshmi Prasanna Adavi. So try to understand from the viewpoint of that. Suppose if you are traveling somewhere, suppose you have to go straight, then take this, or instead, directly if there is a diversion, suppose you have to reach here. In both cases, you have to reach here. Both cases, suppose you have to reach here. Then in that case, and the starting point is this. Now obviously this will be faster, right, as compared to your this. Vacha, Lakshmi Prasanna Ravi. Suppose this is 3 meter, this is 2 meter, total will be 5 meter. But this, if I directly take this, this probably will be a 4 meter. So you are saving 1 meter. So your way, movement of men or material will be minimized. This person himself will take it, and it's in the same cell. It's like a cabin that is given. So that cabin only internally, then from milling department you will take to the cutting department. Waste of movement of waste of time, movement of process, men, material will be reduced to a greater extent, and yes, this issue is resolved. Working capital block. See, working capital block was the case where there used to be creation of WIPs. Here there is no WIP which is going to be created, because this one person is responsible for that one product. That is why this is also called as single piece flow. This system is also called as single piece flow, because in one flow, you are able to complete the whole product. In one flow, you are able to complete the whole product. So that is called as single piece flow. That is called as single piece flow. So then now I am the operator. Because these are smaller machines, their capacity is almost same. So if I can make 20 units per hour here, 20 units per hour will be made, 20 units per hour will be made. No WIP will be developed, because there the machines were different, the operators were different. Here the operator is same. So he will ensure that no WIP is created anywhere. If no WIP is created anywhere, your WIP capital which was blocking is now not going to be blocked. Done. No WIP, no storage cost. Rectification of defects. Was this person is there, no? As soon as drilling is done, you will check. Drilling is done properly. As soon as milling is done, milling is done properly. As soon as the cutting is done, cutting is done properly. Then only assembling will happen. Suppose if drilling is done properly and then after milling, he sees that, oh, milling is not done properly. Immediately, he will do the milling again. Issue is resolved. You don't have to go back from assembling department to drilling department to again do the milling department to again do the cutting. No, there's one person who's taking care of all of this, and he will see milling is not done properly. Immediately, he'll get it resolved. Hey, Samjigudu. Hey, Samjigudu. Yes. So, rectification of defects which used to happen at the last stage, and as a result of which the whole process cycle used to be followed, will now not happen. Lack of customization and flexibility. Now, lack of customization was the issue there, because there were big machines, only one way of doing things. Your customization can be done. There is one operator, I can tell, hey boss, cutting of this should be round shaped, cutting of this should be square shaped. He'll do it that way. Small machines, easy to adjust, easy to configure. Are you understanding? But there is no division of work, as the process takes more time than expected. This process takes lesser time. Yes, try it out. I have done an experiment, and this process takes more time. I have done an experiment wherein I have tried two methods, this method and the traditional method, and made a product. And it took me 2 minutes in traditional, 1 minute 35 seconds in cellular manufacturing. I'll let you know what is to be done. Lakshmi Prasanna Adavi saying cost incurred in this process wouldn't be more than the traditional. I don't think so. And plus, see, look at the incremental benefits. Agreed, chalo. Even see, it will not be more. Even if it is more, then in that case, the scrap will be reduced to a lowest level. There will be no storage cost involved. There will be no WIP involvement. There is no working capital block. So you are saving also no so much money. Huh? Tell me. So by default, that will be offsetted, and benefit will be much higher. Quality product will be much higher. So that is taken care of. Lack of customization and flexibility is taken care of, because small machines are there, easy to set up, easy to do all of these things. Even if one machine stops, all production comes to a halt. If in the original case, traditional manufacturing milling department stops working, then product A, B, C, D, E, F all stop working. Production of everything gets stopped, right? But here I am making product A in this cell 1. In this cell 1. Suppose if mill 2 stops, if mill 2 machine stops, if there is an issue here, this machine stops, still my product B, which is working on cell 2, will go on. My product C, which is working on cell 3, will go on. My product D, which is working on cell 4, will go on. Are we understanding, Machas? So the whole production of the company is not stopped. It does not come to a halt. Everything will go as it is. Yes, only this will stop. Plus, because it's a small machine, we can rectify it easily, quickly. Game over. Yes, sir. So, again, This is also taken care of. Lack of autonomous maintenance was there. Here autonomous maintenance is possible because small machines we will train and do. High setup time there. Here the setup time will also be low. Small machines quickly you can set up. You can set up for small batches. You can set up for small number of units. Sir, here with this I rest my case. I conclude my presentation. Sir, if you have liked it, you can clap it from wherever you are and give me the approval for creation of cellular manufacturing. So please tell me, sir. Any questions that you can ask me? See, guys, you are the CEO, CFO of the company. Congratulations. Yes. So, and I am your production manager. I have presented this to you. Did you like this? If you have any questions, you can tell me. If not, we'll move on. Last point, please. Again, sure, Kiran. Last point is autonomous maintenance. In that original traditional case, big setups, big machines are there. It is not. Acha, that one machine stops the other flow. Okay. That one. Okay. See, I'll tell. In case of original traditional manufacturing, if the milling department stops working, then in that case, see, all the products which needed the milling department, product A, B, C, D, everything will stop. Everything will stop because everything has to pass through the milling department. But milling department is not working, that machine is not working, so all of the product will get hampered. But in case of cellular manufacturing, because there are small machines, we will have multiple cells, and in that multiple cells we will have multiple machines working. So because one machine is not working, that will not hamper or stop the production totally. Other cells are going on, other products are going on, everything else. So there will not be only one milling machine, there will be 2 3 4 milling machines where the work will go on. Production will keep on going on a continuous basis. Are we understanding, guys? Tell me, Kiran, now did you understand? So just because one milling machine stopped in traditional, the whole production came to a halt. Will not happen here. Will not happen here. In cellular manufacturing also, process will stop if one machine breaks. Yes, macha, Pastor macha, yes. But that will happen only for one product. We have multiple cells. Other products will go on. There in traditional manufacturing, all products will go for a task. Gotcha, Paski, my boy. Yes, Lakshmi Prasanna Davi has understood it, and so there are. I am the fish. You guys are the sharks. The sharks have given me the positivity that yes, you can implement it. They still have some more questions before they give me the equity. But that doesn't affect all other products. And also person will be trained enough to rectify the breakdown. Yes, Lakshmi Prasanna Davi. Because these are small machines, it's quite possible. Sharks, any other questions? Okay. Kiran, that is product wise division of machines, right? Yes, Kiran, absolutely right. Hey, Baskima boy, where are you? Are you clear? Done, guys? Done, sir, done. Got it. Finally, I have got the permission from my sharks to implement cellular manufacturing in my company. Now, I will start with the process. Before that, you can just go through this. You can write this down. Yes, thank you, Raj. Finally, Raj was not replying at all. Finally, she just said, understood, sir. Cool. Okay, officer. Done. So now please have a look at this and then we will start with Roca. So see here how step by step smoothly we've been tackling this. Done. Done. Now implement cellular manufacturing. In order to implement cellular manufacturing, we will use the system of Roca, 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 Roca. Chal. Please go through this 2 minutes and we'll start. Okay, so with the flow, now we are going to start with the concept of ROCA. So ROCA, rank order clustering algorithm, is basically a technique of implementing cellular manufacturing so that the cells are kept with proper machines. So there are a lot of products that a manufacturing company is going to make. For that, lot of machines would be required, some identical, some different. How do you arrange the machines? Because there will be products which will require some common machines. There will be products which will require some different machines. So that can create a confusion. See, so what happened is now all of this look good, but when they started implementing it, they started facing these practical issues, and that's where they realized that okay, we should have some system which will tell us what cluster of machines should be kept where, and that gave rise to the concept of ROCA, rank order clustering algorithm. Now we are going to start directly with a sum relating to ROCA, and once we are done with that, then we will realize that okay, how the whole cluster works and everything, and then we will do the theory related to cellular manufacturing and ROCA. So I hope the system is very much clear now. So we started we started with CA foundation, which is traditional manufacturing, then cellular manufacturing system, then ROCA. ROCA is sums, and then finally we will do the theory of cellular manufacturing and ROCA. Cellular manufacturing and ROCA. So last point I'll just write here. Fourth point is theory of cellular manufacturing and ROCA. And ROCA. Copy this. Chal. So now shall we start? You can find this in May 21 RTP question number 4 that we are now going to solve. Yes, that's I told you. That's where it was probably introduced through. This is the theory relating to ROCA which we will be doing as I said in the end. And now here we have the sum, the sum, the sum. Are we ready? Yes, sir. Yes, we are. See, these are the some steps given for solving, but obviously you will not understand any step till the time you have solved it. So let's come here. It's going to be more of like a video game going on. Nice question. Chalo, let's start. Yes, let's start. Sure. Question on ROCA. Are we ready? Sure. Pay full attention when I am teaching this, huh? Please. Nazar Bhati, Durgatna Ghati. It has been resolved. Please open this question. Coincidentally, it is question 4 of May 21. It has been resolved that last. You will see it in the last part of your book probably. Yeah. So it has been resolved that cellular manufacturing shall be adopted in order to improve productivity in the recent board meeting of Raptor Bearing and Shaft Limited. Even our board meeting, it has decided now. In favor of resolution, Mr. Nayak, the executive director, who is responsible for the production and operation function, gave a briefing over different layout of cells. The managing director, Mr. Sial, believes that each possible cell formation and layout need to be studied in advance by a cross-functional team. Very true, very true. Chief HR Officer Mr. Misra shows his concern over the utility of cellular manufacturing to enhance productivity. In response to him, Mr. Nayak mentioned, although scientific management is quite an old theory for management pronounced by Frederick Vincent Taylor. Have you heard his name, Frederick Taylor? You would have heard his name in IPCC CA Intermediate Costing, Labor Costing. Taylor differential, Merrick differential, he is that Taylor. He has just done a PhD on time and motion study, which is what cellular manufacturing is all about, which analyzes and synthesizes the workflows with objective of improving economic efficiency, especially labor productivity, but still has relevance. This relevance multifolds when time and motion studies are considered in nexus with cellular manufacturing. Mr. Nair constituted a cross-functional team with the term of reference stated in said board resolution. You are also part of teams as a representative of management accounting division. So now here cross-functional teams are set up. So what is a cross-functional team? We'll understand it when we do chapter number 8, performance measurement and evaluation. But still, for your reference, cross-functional team means suppose you are working in X department. Suppose some other person is working in Y department. There could be a new department Z wherein X department's person and Y department's person could also be working together. So that is called as cross-functional team. That is called as cross-functional teams. Okay. The team started with different possible layouts and machine cell designs. While analyzing the production flow, it is observed that 5 different parts, or what you call components, are complexly involved in processing at 5 different machines. Oh, so 5 different machines, 5 components, too much confusion, too much fun. Part machine incident matrix for production flow analysis for the SAT product is given below. P 101, 104, 105, 107, 108, M2, M7, M13, M13A, 15. See this right there. These are machines for your understanding, and this is products. All of the thing written here is of no importance to us. This is where the real Roca starts. Interpretation. The interpretation is very simple. In order to make product 101, you require machine M2 and M13. In order to make product 104, you require machine M7, M13A. In order to produce product P105, you just need machine M13A. In order to make product 107, you need M13, M15. In order to make P108, you need machine M7. Simple interpretation. Discuss the concern by Mr. Mishra over utilizing cellular manufacturing. So here you have to explain the advantages of cellular manufacturing. Explain the utility of at least 3 machine cell designs which can be used. This is again theory. And the last part is now what we are solving. See, the first 2 part is theory, which we are yet to discuss. I told you that there are 4 parts to this. There are 4 parts to this, and this fourth part will be done later on. This fourth part will be done. This part will be done later on. Okay. So now let us start with the third part, which is find the logical part families and machine groups based upon part machine incident matrix to showcase machine part grouping using rank order clustering algorithm. Yes, guys, let's start. So So this starts with steps of Roca which has to be followed here. Let's start. The first thing that we need to do, is make the matrix as it is. The first thing that we need to do is make the matrix as it is. But please, you do not do that mistake of making it without me. Please do not do that mistake of making the matrix without me. Please let me be involved into it, and then we will do it together. Okay? Okay? Okay. So, shall we start? Shall I start? Okay. See here. Now, there are 5 machines and there are 5 products. Ensure that if you want, you make a +2 +2. So 7 by 7 matrix is what we need to make. 7 by 7 matrix is what we need to make. 7 by 7. So 1, 2, 3, 4, 5, 6, 7. We can make a little bigger. 1, 2, 3, 4, 5, 6, 7, and then 2, 3, 4, 5, 6, 7. Okay, so then see here what they have written: products machine. So we will also write that. We will also write that. So let's write this products is called as J. Products J, and machines is I. Okay, then P 10. So I'll just directly write P 14578. 1 4 5 7 8. M 2 7 13 13 A 15. M 2 7 13 13 A 15. Gotcha? Gotcha? Then you have to mark it. So in order to make P101, you need machine M2 and M13. You need machine M2 and M13. In order to make P4, M7 and M13A. P1 5 M13A. 7 M13 M15. 108 1. Okay, done will till here. Now there are 2 things, P, W and D, E, I. 1 2 3 4 5 6 7. Oh, we need to make 8. I'm so sorry. We'll have to make 8. Okay, now we have 2 more concepts. One is called as BWJ, another is called as DEI. BWJ and DEI. And what is BWJ? BW is called as binary values. See, there is obviously a derivation for all of this. But getting into derivation will not make sense because this is just one of sum, and derivation will itself take your 5 to 8 hours. So doesn't make sense at all to get into that binary weights, because for this you should also know OR, operations research, which you don't know because you were not there in old syllabus. So I have done old syllabus, now I'm teaching new syllabus, so I know what we had in old syllabus. Operations research, this is a part of operations research. So first to teach you operations research and then to teach you technically how it is derived doesn't make sense. Investing so much time, it's like it will become like a non-value added activity that way. Otherwise, there's no problem. Yeah, probably after you are a chartered accountant, we can try for it if you would be interested, which you will not be, I'm sure. Because once you become CA, then you are like, oh, come on, we don't care. Hmm? Chalo. Then we have DE. What is DE? It is called as decimal equivalent. It is called as decimal equivalent. Are we done? So BWJ, DEI. Chalo. Now, what is PWD? How do you calculate this? How do you calculate this? See, I have given the formula also, but I'm sure you will not understand even a single word from that. Still, I'll at least show you how does it work. See here. Assign binary weight to each column. So assign binary weight to each column. Column, 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 column. We are focusing on the column. So binary weights are assigned to the column initially. Then 2 raised to n minus j. So what is 2 raised to n minus j? I'll explain. No, don't worry. 2 raised to n minus j. This n is number of rows. This n is number of rows, right? And then 2 raised to n minus j. J is, you have to write the number of rows in ascending order. Right? Number of rows in ascending order. Okay, so let's write this down. BWJ 2 raised to n minus j. So 2 raised to n. What is 2 raised to n? 2 raised to 5. Number of rows. This is fixed. 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 Minus. Write number of rows in ascending order. 1, 2, 3, 4, 5. I told you, you will feel as if some video game is going on. Chalo. So Kiran is asking who will draft these questions. Internationally, these questions are already drafted. ICI has just picked up and pasted here. Chalo. So first step, you see again, steps are given here. You can follow this. First is BW, binary weight. How do you calculate binary weight? I have written here 2 raised to n minus j. N is number of columns. 5, 5, 5, 5, 5, 5. Minus j. 5 is constant. That n is constant. What is j? Tell me what is j? Write number of rows in ascending order. 1, 2, 3, 4, 5. So 2 raised to 4 is how much? 2, 2 is 4, 2 is 8, 2 is 16. 2 raised to 3, 8. 2, 2 is 4. 2 raised to 1, 2. 2 raised to 0, 1. Got it? Got it. Now we have the decimal equivalent. Now we have the decimal equivalent. So what is decimal equivalent? Let's see. Decimal equivalent of each row is very simple. You just have to add the numbers. So how does it work here? In case of M2, now here we are calculating DEI. We are calculating DEI. In case of M2, just here M2, there is this P1 that you can see. Can you see this P1? What is the value of P1? This row. Now you have to focus on the rows. Rows you can see M2. Which row can you see? M2. M2 value we will have to write down. So in M2, How many ones can you see? This one P on one P1 you can see. Any other that you can see here? So we are confused. Okay, I'll tell you. Don't worry. Don't worry. How is it gone? Yeah. See, it's very easy. DEI is very, very easy. In fact, easier than uh, BW also. So see here, I'll show you. Have I copied it wrongly or what? Seems. Hmm. Think there's a copying drafting. Just a moment. Huh? See here. So M2, focus on the row. Row has P1. Take the value of this, which is 16. Take the value of this, which is 16. So here what is the value? 16. We will write here 16. Sir, did not get you. Again I will do. Come to next row, M7. Come to next row, M7. Now M7, what do you see there? In M7, what do you see? In M7 there is P4 and P8. In M7 there is P4 and P8. Right? So in M7 there is P4. In P4 there is this 8. And in this P8 there is this 1. So 8 plus 1 is equal to 9. 8 plus 1 is equal to 9. Then third. Getting it, my friends. Getting it, my friends. Next. M13. M13. P1 is there, which is 16. And P7 is there, which is 2. So 16 plus 2, 18. Then M13A is there. 8 plus 4, 12. M15, 2. Are we understanding? So this is your DEI. This is your DEI. Decimal equivalent. A. Samjigiru. Are we clear? Now we have to give the ranks. Almost the last step. As in not the last step. Still a lot of steps are left. But in terms of understanding this table. Now we have to give ranks. You tell me, who gets the first rank? More marks or less marks? Sir, more marks get best rank. So first rank 18 marks. Second rank 16 marks. Third rank 12 marks. Fourth rank 9 marks. Fifth rank 2 marks. A. Samjigadu. A. Samjigadu. Are we clear, everybody? So 1, 2, 3, 4, 5. Awesome. What did I say? Awesome. So with this, the first step is concluded. Sir, so is the answer achieved? Answer will be achieved when the ranks come in the ascending order. Answer is achieved when the ranks come in the ascending order. So I'll write here, final solution is achieved when ranks are in ascending order. That is 1, 2, 3, 4, 5. Is that the scene now? Is the ranks in the ascending order? Is the ranks in ascending order? The answer is no. And so we will have to start the process again. How do you do the process again? I'll show that to you. I'll show that to you. How do you do the process again? I'll show that to you. Don't worry. Don't worry. So again, we have to just draw this same 8 by 8 thing again. Just see here. A 1, a 2, a 3, 4, 5, 6, 7 and 8. 1, 2, 3, 4, 5, 6, 7 and 8. See here. Now. Hold on. Okay, sir. Hold on, sir. Let us take deep breaths for this. Okay. Take deep breaths for this. See here. Just have a look at this. Just giving you all 2 minutes blankly to observe, and then I'll move on. Just giving you 2 minutes blankly to observe it. Come on. Okay. Okay. Now. So now next step. See, final answer will be when ranks are in ascending order 1, 2, 3, 4, 5. But now we start with the next step. So next step is probably, if that step you are clear, then you are clear with the whole concept. See now, again in the next you have to write down the machine names P1, P4, P5, P7, 8, P4, P5, P7, P8. Okay. Then you have the machines. Now machines will be written as per the ranks. The machine will be written as per the ranks. What is the first rank? Sir, M13. Next rank, M2. Next rank, M13A. Next rank, M7 and M15. Gotcha? 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 Okay. So now we will again start, but in the second, see, alternatively your BW will change. Now BW will go from column to row. BW will go from column to row. Binary weight will go from column to row. Okay. And where will your DEI go? Decimal equivalent will come here. This is I. This is J. This can be interchanged. Now this will become J. This will become I. That's okay. Now we will start with the numberings. So tell me, what is the numbering for that we can see for M13? Tell me the numbering for M13, guys. Tell me the numbering for M13. Tell me, I'm asking you. Tell me the numbering for M13. M13 is 1 and 7. So we will write here M13 1 7. Then M2. M2, what is the numbering? Only 1. Only 1. M13A 4511. 4511. M7 4811. M15 P71. Gotcha. Gotcha. Okay. Same thing here. 2 raised to 5 minus 2 raised to 5, 2 raised to 5, 2 raised to 5, 2 raised to 5 minus 1, 2, 3, 4, 5, 16, 8, 4, 2, 1. Yes, now you are getting the hang of it. Yeah, buddies, come on. Now you have to say DE. What is it? DE will be this 16 and 8, 24. Did you get it? Then P4 will be 4 plus 2, 6. Then P5 will be 4. Then P7 16 and 1 17. Then P8 2. Gotcha. Gotcha. Okay. And now finally, that's your right. Time to give the ranks. Let's pray it is 1, 2, 3, 4, 5. 1. 2, 3, 4, 5. So now we will repeat the process again. Now the BW will go down, DE will go up. But remember, now the ranks are from P1, 4, 5, 7, 8. So first you will draw M13, M2, all of that. So just to give you an idea, first now first you will draw this, just a moment, 3 and 4 and 5 and 6 and 7 and 8, 1 and 2 and 3 and 4 and 5 and 6 and 7 and 8. First, see now here this P1, P4 will change as per ranking, but M13, this will remain as it is. 2, 13A, M2, M13A, I think M7, M15. See, because the rankings gone down, no? So now rank 1 is for P1. So we can write here P1. Rank 2 is for P7. Rank 3 is for P4. Rank 4 is for P5. Rank 5 is for P8. Hey, Samjagiru. Yes. Now, I think now you should start the process. Now you can solve this. Try. I mean, obviously, the first time I will do it. Don't worry. Don't get scared. I'll do it. But still, yeah. You can at least now it is becoming thinkable for you. Right. Chalo. Come on. What's it? Chalo, shall we continue? You have written it. Okay. Chalo. So now We have P1, P7, P4, P5, P8. Now, we have written everything as per ranks. So, M13 requires what? M13 requires P1 and P7. So, P1 and P7. Are you understanding, guys? P1 and P7. Then we have M2. We have P1 only. Then we have M13A. We have P4 and P5. Then we have M7. We have P4. Then we have M15. We have P7. Okay. Then we have M7. We have P4 and P8. Okay. Okay. Now BW and then DE. Things are looking easy now. Yes, BW. Let's start with BW. And then we have the DE. And then we have the ranks. Okay. 2 raised to 5 minus 1. 2 raised to 5 minus 2. 2 raised to 5 minus 3. 2 raised to 5 minus 4. 2 raised to 5 minus 5. Okay. 2 raised to 4 is 16, 8, 4, 2 and 1. Right? And then we do the ranks. No, so then we do the DEI. So first is this M13 row. So we have 16 and we have 8. This is 24. Then we have 16. Then we have 4 plus 2, 6. Then we have 4 plus 1, 5. And then we have 8. And we will do the rankings. And you will be heartbroken. You will be heartbroken. Just see this. 1, 2. Just missed. Just missed. Just missed. Now what will you do? Restart the process again. Restart the process again. Come on. Come on, Charlie. 1, 2, 3, 4, 5, 6, 7, and 8. And then again we have 1, 2, 3, 4, 5, 6, and 7. Alright. Now look at the ranks. Your ranks will decide what is going to change, what is not going to change. So ranks is for the row, which is M. So P1, P7, P4 will remain as it is. P1, P7, P4, P5, P8 will remain as it is. M, this will change. M13, M2, M13, M2, continuing, M2. Then third rank is M15, M13A, M7. Okay. So quickly, what do we do? First, BW. Last time BW was here, so now BW will be here. Then DE. Okay. Now let's do the numbering. 1, 1 for M2, 1, M15 is P7. See now, in so you have to be very attentive. P4, P5. At times you may make a mistake here. And P4 and P8. Okay. 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 So quickly. 2 raised to 5 minus 1. So now we know this, so no need to write it separately. 16, 8, 4, 2, 1. If it was 6 rows, then it will be 32, 16, 8, 4, 2, 1. If it is 7 rows, 64, 32, 16, 8, 4, 2, 1. Acha. Okay. Then DE. So here P1. So 16 plus 8, 24. Then P7, 16 plus 4, 20. Then P4, 2 plus 1, 3. And P5 is 2. P8, is 1, and here we have ranks as 1, 2, 3, 4, 5. Wow, would you believe it? We have got the ranks as required. We have got the ranks as required. Some, some. Please have a look. Please have a look. Please have a look. So now, sir, how do we distribute? Very simple. Very simple. The distribution starts now. So you better pay attention now. Okay. So here we will write down. Here we will write down. Since ranks. Any doubts or any questions? Live students, any doubts or any questions, or are you clear? Since ranks are in ascending order, we have reached the solution. We have reached the solution. Okay. Yes. Cool. Now, most important part, how do you allocate? See here. So now, as can be seen, that we can make a cluster of, can I say, M13. This can be one cluster. M13, M2, M15 can be made, can be kept together, and in that we can make P1 and P7. Correct. And then here we can make M13A and M7 together, so that we can make P4, P5, P8. Are we clear with this cluster? So logical. Lakshmi has a question, sir. Why did we not change products like we did in third step? No, we change it, no? See here. See, try and understand. Lakshmi, try and understand. Here the ranks were in M. So we changed M. Then the ranks were in P1, P4, P5. So we changed the products. P1, P4, P5. See here, P1, P7, P4. Then the ranks were here. Lakshmi, the ranks were there for M. So we changed the machine. See here, M15 was third rank. So now here M15 is there. Lakshmi, are we understanding? See, these are type of sums which you have to solve. Sir has explained the steps, right? Okay, it's gacha. Gacha, everybody. Yes. Cool. Got it. Lakshmi has said she has got it. And finally, this is our solution. Finally, this is our solution. So we will say, as per above, what is the machine cell or cluster that we are going to make? First cluster that we are going to make is for M13, M2, M15. Machine M13, M2, M15. And then we have the products. Then we have the products. Products that we are going to make here is P1 and P7. Then we have cluster 2, M13A and M7. Products P4, P5, P8. Got it? And this is the final solution. This is the final solution. Bacha. Chalo, please write it down. Write it down.